Hello everyone and welcome. This is Russ LeBlanc, NEC consultant, and in this video I'm going to be explaining load calculations. Specifically, I'm going to be looking at branch circuit lighting load calculations for dwelling units using the 2023 codebook. So I would grab your codebook and a calculator and we can dive right in to these requirements. Okay, Article 220 is broken up into several different parts, and we're not going to be looking at all of them, just a couple. Certainly part 1 and part 2. All right, part 1, general requirements, including the scope. We need to have a good understanding of what this article covers. All right, so if we take a look at that, 220.1 says this article provides requirements for calculating branch circuit, feeder, and service loads. That's it. It's just for calculating loads. Can't size wires, can't size breakers. You have to leave Article 220 to do that. All right, so it's just for calculating loads. If you want to size wires or overcurrent devices, you'll need to take the information from the load calculation in Article 220 and go to Article 210, for example, if you are figuring out how many branch circuits you need for lighting. Or if you're sizing feeder conductors, you go to Article 215 with the information from Article 220 calculations. And for services, you would go to Article 230 with the information from the Article 220 load calculations. There are so many rules throughout the codebook that are based on load calculations, and those load calculations are typically performed using Article 220. All right, so that's what we're looking at today. Now in 220.3, there's a table letting you know that there are other requirements in the codebook, just as I mentioned, 210 and 215 and 230. Table 220.3 has requirements for specific purpose calculations that aren't in chapters 5, 6, or 7, right? Remember, chapters 5, 6, and 7 can amend the general rules in chapters 1, 2, 3, and 4, right? So we don't really need to specify that in 220.3. That's just how the code works. But for rules that aren't in chapters 5, 6, and 7, well, then we probably need a heads up that, hey, you know what? Not all the calculation rules are in Article 220, right? So take a look at Table 220.3 if you're dealing with any of those specific calculations, okay? All right. Moving on to 220.5. As far as which voltages should we use? Well, so we all have the same number. We all get the same math. 220.5a says unless other voltages are specified for the purposes of calculating branch circuit and feeder loads, nominal system voltages shall be used. And they're all assigned there in 220.5a. Right? And nominal voltages are just an assigned voltages, and they're all assigned there in 220.5a, including the ones on the screen. 120 volts, 120, 240, 208Y, 120, 240 volts, et cetera, right? So use those, the assigned nominal voltages. Don't use nameplate voltages. Don't use equipment voltages, right? And don't use voltages like this. Don't use 110. Don't use 115, 220, or 230, right? Those might be the voltages your meter reads, or they could be on a piece of equipment. Do not use those voltages, right? Unless you have other information that says otherwise, use the voltages specified in 220.5a. Okay, next we want to talk about what to do with a fraction of an amp. When we have a calculation and we have a fraction of an amp, what do we do? Well, 220.5b says, calculations shall be permitted to be rounded to the nearest whole amp with decimal fractions smaller than 0.5 drop. That's a permissive rule. You don't have to do any of that. If you want to keep the decimal, you can keep it. If you want to drop it, you might be able to drop it if it's smaller than 0.5. If you want to round up, you can do that. If you want to round down, you can do that. right? It really depends on what you're trying to accomplish. And for exam purposes, if your question might be worded like something like, round to the nearest whole number or something like that, well, in that case, you have to round, right? It is not optional anymore. All right, but in the real world, not for testing purposes, you can leave the fractions if you want to, or you can drop them if you want to. It's really your choice. Right? Decimal fractions smaller than 0.5 can be dropped. They're not required to be dropped, though, right? They can be if you want to. All right, rounding up or down is permitted. Either way, your choice. All right, but then the question becomes, well, when should we round? Right? It says calculations can be rounded. If I just give you a nameplate amperage, don't round that because that's not a calculation, right? For example, if I say load 1 is 20.4 amps, don't drop that down to 20. You haven't calculated anything yet, right? That's just a nameplate amperage. Keep it as 20.4, right? So we have load 1, 20.4. Load 2, also 20.4. Load 3, 20.4. Load 4, 20.4. Don't drop any of those 0.4s. Keep them, right? Round at the end, right? Otherwise, you might have something like this, 20. If you drop them, right, just the amperage on the nameplate, you drop the 0.4 amps, then you end up with 20 plus 20 plus 20 plus 20 for a total of 80. Versus if you keep that nameplate decimal of 0.4, you end up with a total load of 81.6 amps, right? So now if you're dealing with whole numbers, you can round up to 82. That's a big difference, right? 80 versus 82, right? That could be a different size breaker. That could be a different size wire. So I would round at the very end. Now, the code doesn't say exactly when to round, just that calculations can be rounded. And so if you've done a calculation, you can round to the nearest whole number and drop decimal fractions smaller than 0.5 if you want to. All right, so here's an example of that, right? So these are just givens, right? Then it's nameplate information, it's equipment information. Don't drop any of those fractions. Don't round up, don't round down. Keep them. Do the math, then decide. All right, so let's do the math. The math works out to 78.49. Now you decide, do I drop that decimal or do I keep it? Do I round up? Do I round down, right? In this case, you have permission to drop that 0.49. So if you want to, and if the question is worded such that you can round down, then round down and call it 78 if you want to. Here's another example, right? Don't drop any of those fractions or round up or round down. Just keep them, and then at the end, decide what to do. All right? So the math, in this case, works out to 78.5. You do not have permission to drop the 0.5 amps. You have to keep that, right? So it's either 78.5, or if you can round up, you can call it 79. That's permitted. You have permission to do that. All right, let's talk about calculating the floor area. 220.5c says the floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. So don't go room by room and add up, the square footage of room 1 plus room 2 plus room 3. Don't do that. You look at the outside area, right? And that's it, the outside area. It also says for dwelling units, the calculated floor area shall not include open porches or unfinished areas that aren't adaptable for future use as a habitable room or occupiable space. It also used to include garages, right? It said you didn't have to include garages there, but they got rid of, for 2023, they got rid of the reference to garages. So I would include the floor area of a garage, and it makes sense because there is typically lighting there, right? So again, use the outside dimensions of the building. Don't go room by room. And each floor. So if it's a house and there's 2 floors, you got to do floor 1 area plus floor 2 area. And if there's a 3rd floor, it's plus the 3rd floor area. Right? So don't include any of those spaces like open porches or unfinished areas that wouldn't be used as a habitable room or occupiable space. I would include the attached garage now, right? It doesn't specifically say to do that, but knowing that they removed it, from being excluded I think the intent is to include it now in the area. I would not include an unfinished attic like this, right? This unfinished space, it has a floor, but this would never be adaptable as a habitable room or an occupiable space, right? You don't have the headroom. There's probably not ventilation. So I wouldn't include it. I would include the garage, though. An attached garage, I would absolutely include it. There is lighting there. Include it in the floor area with the rest of the house. Okay, on to part 2. And again, we're focusing on branch circuit calculations for lighting in dwelling units. And if you forget, either on the exam or out in the real world, in the back of your code book, Annex D, there are several calculations there for calculating loads in Article 220. There are some very good ones there, so if you get stuck, you can take a look at those, and they have a pretty good template there to hopefully get you through where you might get stuck. Okay, we want to look at 220.10. Right? It says branch circuit load shall be calculated in accordance with the following sections. There are 5 sections there. I'm not looking at all of them. We're only going to look at number 3. 220.10 number 3 says for dwelling units, you have to look at 220.41, which is actually part 3, feeders. Right? So we are going to use the feeder calculation method for calculating branch circuit loads in dwellings. All right? That's what we're going to do. And if we take a look at 220.41, let me scroll there. Again, that 220.41 is actually in part 3. But that's what we're going to use to calculate branch circuit lighting loads. 220.41, dwelling unit minimum unit load. And it says you're going to use 3 volt amps per square foot minimum to calculate the branch circuit lighting load in a dwelling. And it also says in 220.41 that the unit load includes the following: lighting and receptacle loads. No additional load calculations are required. And we're going to look at the specific wording there. But generally speaking, all the lighting and receptacle outlets are included. Okay, here's how you do the math. The minimum lighting load is determined by multiplying 3 volt amps per square foot times the floor area. And it doesn't matter which you do first, right? You could do the floor area times 3 volt amps per square foot. It doesn't really matter. Either way. Okay. Let's take a look at the specific wording in 220.41. It says the 3 volt amps per square foot unit load includes the following: lighting and receptacle outlets. No additional load calcs shall be required. Item 1. All general use receptacle outlets of 20 amps or less, including receptacles connected to the circuit specified in 210.11c3 and 4, which is bathrooms and garages, right? They might be 20 amp circuits, but those receptacles are included in this 3 volt amps per square foot. Item 2 says the receptacle outlet specified in 210.52e and g, which is the outdoors, basements, garages, and accessory buildings and dwellings. Those receptacles are included in this 3 volt amps per square foot. And then item 3 says all the required lighting outlets, all included in this 3 volt amps per square foot. No additional load calcs for any of these items. It's all built into that 3 volt amps per square foot. The last sentence in 220.41 says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered part of this minimum lighting load. That's cool. So there's no load calc for those either. Right? Something like a paddle fan or a bathroom exhaust fan, right? Any of these small motors, less than 1/8 of a horsepower. If they're connected to the lighting circuit, well, then they're just considered a lighting load. And there is no load calc to do. It's built into the 3 volt amps per square foot. All right, let's do a floor area calculation. All right. In this case, the house is 62 by 24, so we want to find the total floor area. And it doesn't matter to me what you call that 62 feet or the 24 feet. Is it the front of the house, the back of the house, the right side, the left side? length, width, I don't care. It really doesn't matter. It's a 62 by 24 foot house. So just multiply 62 times 24, and you get 1,488 square feet. That's the square footage of this house. And that's it. That's how you calculate the floor area. You might also write it like this, 1,488 feet squared or square feet. Either way is okay. Let's do another example. This time we're going to have 2 stories. First floor is 48 by 22. Second floor is 50 by 22. We're going to add those two together. All right, there's a visual there. All right, so the math works like this. First floor is 48 by 22 for a total of 1,056 square feet. Second floor is 50 by 22 for a total of 1,100 square feet. We have to add those 2 floors together. And that math works like this, right? 2,156 square feet total. That's the floor area. That's how you do it. If there was another floor, well, we would calculate the floor area for that floor and just add it into the mix. All right, now let's do a lighting load. All right, so we know how to calculate the floor area, and the lighting load, minimum lighting load is 3 volt amps per square foot. So let's put those 2 things together now. For this example, we're going to use a 2,000 square foot house. It's pretty simple. 2,000 square feet times 3 volt amps per square foot, 6,000 volt amps of lighting load. That's it. That's the branch circuit lighting load, 6,000 volt amps. You're done. Now, you might want to do something with that information, right? You probably just don't want to do load calculations for the heck of it or for the fun of it. You might want to figure out how many branch circuits you need for this, for example, right? And I think a lot of people use 15 amp circuits. So let's do that. Let's calculate how many 15 amp 120 volt branch circuits I would need for this 2,000 square foot house with 6,000 volt amps of lighting load. All right. So if you look on the screen there, each 15 amp circuit at 120 volts provides 1,800 volt amps per circuit. So we have to distribute that 6,000 volt amps among those 1,800 volt amps circuits. All right, so there's that math. 6,000 volt amps divided by 1,800 volt amps per circuit. That equals 3.33 circuits minimum. Now, you cannot round down to 3 circuits. There is no code rule that says you can drop a fraction of a circuit, right? The rules we read in 220.5 says you can drop a fraction of an amp when it's less than 0.5. There's nothing that says you can drop a fraction of a circuit. There's no such thing as a third of a circuit breaker. That means you need 4 circuits minimum. You can't say 3 would be enough. It's not. You need a minimum of 3.33. That means you got to put 4 circuit breakers in. And that is according to 210.11a. The minimum number of branch circuits required is determined from the total calculated load and the rating of the circuits used, right? And in our case, we were using 15 amp branch circuits. All right, let's do another example. In this case, we want to figure out the minimum branch circuit lighting load for general lighting and receptacles. The house is 62 by 24, right? And we know, if you remember from one of the previous examples, that's 1,488 square feet. 1,488 square feet times 3 volt amps per square foot is going to total 4,464 VA, right? There it is again. 62 times 24 is 1,488 square feet. That's the floor area. Now multiply that by the unit load, or 3 volt amps per square foot. 1,488 square feet times 3 volt amps per square foot equals 4,464 VA. That's your lighting load, your branch circuit lighting load. What do you want to do with that? I want to calculate number of branch circuits needed. Okay, let's do that. Well, again, we're going to use 15 amp 120 volt branch circuits. So we have to take that 4,464 and divide that equally among those circuits. Okay, right? This is just continued from the previous slide. So we have 4,464 VA of calculated load for branch circuit lighting and general use receptacles. How many circuits are needed? We're using 15 amp 120 volt circuits. Now, I want to point out, do not use the demands in table 220.45. You can do that if you're sizing a feeder or a service. We're not doing that, right? We're only calculating the number of branch circuits, so you don't get to apply the demands from 220.45, right? And that section even says that. This table shall not be applied in determining the number of branch circuits for general illumination. I will have another video where we will use that table. We'll calculate the lighting load, the branch circuit lighting load, and then we'll apply the demands from table 220.45, but that's when we're calculating services and feeders. We're not doing that here. We're just calculating branch circuit load and how many branch circuits we need. All right, so in this case, we're going to need 3 circuits. 4464 VA divided by the VA per circuit, which in this case is 1800 volt amps, right? 120 volts times 15 amps, 1800 volt amps per circuit. 4464 VA, that's the calculated load, divided by the VA per circuit, 2.48 circuits. And again, you cannot round down to 2 circuits. You have to have at least 3 circuits, right? And that again is per 210.11a. And that's about all you can do with this general lighting load, is calculate how many branch circuits you might need, whether they're 15 amp or 20 amp, doesn't matter, that's your choice. There are no demands. You can't use table 220.45. That's for feeders and services. We'll do that in another video. Thank you for watching. Hopefully you were able to follow along and you have a better understanding how these branch circuit lighting load calculations are done. For more information, please visit my website, russleblank.net. See you in the next video.